Hi all, myself Amulya Chennaboyena. Welcome back to my Python crash course. Let's get started. Operators are special symbols in Python which are used to perform operations on variables or values. Let's talk about arithmetic operators. Let's consider a equals to 5, b equals to, let's take 6. Addition, c equals to a plus b, c. Z equals to x plus y, z. C equals to a minus b. This is okay. This is addition. This is concatenation. This is subtraction, and this is multiplication. Is equals to a times b. And if you want division, how do you do it? Division, c equals to a by b. See, power, how do you do the power? C equals to, let's take it as 2. Okay, let's take it as 6. A power b, e. One five six two five. Division, floor, c equals to a b by b. If you run c, you get 0, because when 5 is okay, so when 5 is divided by 6, you get something like 0.83 or so. When it is done the floor, it takes the least one, so it's 0. So let's consider the comparison operators. How do you say about the comparison operators? Let's consider x equals to 20 and y equals to 30. So let's take the loops. If x greater than y, print x is greater, else print y is greater. So let's run this. Y is greater. So let's suppose, take the same example and say x less than y. If x less than y, x is smaller, y is smaller. I'm just explaining about the operators. So x is smaller here, so it says x is smaller. If x is equal to y, okay, when you execute it, if x greater than y, then it says x is equal to y. Else, okay, if x double equals to, I'm explaining about double equal to operator. If x double equals to y, it says x is equal to y. Else it says x is not equal to y. Let's use x not equal to y. X not equals to y. X not equal to y. Else x equal to y. It prints x not equal to y because x and y are of different numbers. What if I say, okay, I will take this is much easier for me. So what if I say x greater than equals to y? Than or equal to y. X is not greater than or equal to y. So let's run it. It says x is not greater than or equal to y. Okay, let's consider the same example. I will say x less than or equals to y. Let's suppose consider 20. Both are equal. Let's say x less than or equal to. Okay. X is not less than or equal to y or x less than or equal to y. I have given 20. Then when I run it, it says x is less than or equal to y. As it compares if it's lesser than y or equal to y. But here it just compares if it's equal to y. Here it ignores 20. Even if it's the same, it will say, okay, let's say this, y is greater, y is smaller, because I have given it, so it says that. But then let's do this one more time. X is less than or equal to y, because it compares if it's less than or equal to y. What else we can do? Let's suppose consider the strings. Amulya equals to Amulya. C equals to Shiva. When you run it, A double equals to B. It says true. A double equals to C. It says false. A not equals to C. It says true. These are kind of comparison operators. You can even perform it on top of strings. Logical operators. True. Y equals to false. logical and operation. X and Y. So X and Y returns true if both values are true. If X or Y. Let's say this is X or Y. Logical OR operation. It says true. Both of any, if either of the values is true. And let's think about not operation. X, let's say not Y. Not Y is false, so it should return me false. Logical not operation, it says true. Not Y is okay. Not if Y is false. How about not if X? So X is true, so it should return me false. Yes. So the true if operand is false. How about bitwise operators? Bitwise operators. So let's perform a quick check. Suppose X equals to 18 and Y equals to 6. Let's say X ampersand Y. When you run it, you get the value 2. So this performs a binary operation on top of it. So okay, if you know the calculation, so it does nothing. So what it does is, when we say bitwise operators, when you consider X equals to 18, Y equals to 6, it converts the binary format of it. When I say binary format, it's the zeros and ones. What's the binary form of this? 1 0 0 1 0. And what's the binary format of this? Binary format is 0 0 1 1 0. And when you add these both, it would be 0 0 is 0, 1 1 is 1, 0 1 is 0 again, 0 0 is 0 again, 1 0 is 1. Oh sorry, 1 0 is 0 again, because to be 1 it both has to be 1, so it's number 2. That's the reason how we got number 2. How do we get X or Y? We got 22 because it took 0 0 is 0, 1 1 is 1, 0 1 is 1 again, 0 0 is 0, 1 0 is 1. So when you change this binary format to numbers, you get the number 22. How do we do the x power y? It's number 20. It's number 20 as power performs the XOR operation. XOR operation. XOR of y. So it returns 1 only when only one is available. If 2 ones are present or 2 zeros are present, it considers that 0. How about not of x? Not of x is something kind of not of x. So the x is 1 0 0 1 0. What's the not of x? The opposite of it. So it has to be 1 0 1 1 0. So when you convert it to numbers, you have to get minus 19. And how do we do the bitwise right shift operation? So we have to say x bitwise 2, right shift to 2, it's 4. And how do we do the x bitwise left shift to 2? It's 72. I don't want to go deep into that because we don't use much of them in our Python for our data engineering, but it must be used for data science. But I don't want to go in depth with the bitwise operators as that's a different subject. So, but then these are the operators that you have to use whenever you have to do the bitwise operations. So let's perform the assignment operators. Assignment operators are something where that I'm going to discuss right now. So let's get it started. Assignment operators. So let's suppose consider x equals to 10 and let's know the value of x. It's 10. If x plus equals to 20, then we'll print the x. It's 30. It's equal to, this thing is equals to x equals to x plus 20. Instead we have given x plus equals to 20. How about x minus equals to 20? And we'll print the x. It returns as 10. How about x equals to x by 10? How do we do this? How do we write this in an easier way? X by equals to 10. Then let's go with this and run it. It's 1.0. Let's suppose consider x multiplied equals to 10. X 10. X power equals to 2. And I say x. Then it returns me 100 because 10 power 2 is 100. How about x equals to int of x. Then when you run it, you say 100. You are assigning the integer value of x. Before it used to be decimal, you have 0.0, but when you convert it into integer, it is 100, just 100. And how do we do the percentile operator? X percentile equals to 2. So what do you think the value would be? It's 0, because it's completely divided by 100 is a even number, so even numbers are completely divided by 2. Let me reinitialize it. X equals to 100. Now when I perform the modulo operator with this is not modulo operator, it's the floor division. When I do the floor division, it says 3. How about x ampersand equals to 2? So it's 0. Okay. Oh, it's 0 again. Okay. Because it's a bitwise and how about x or equals to 2? Bitwise OR operation. I want to consider this again. Next value 1 or 2. Okay. How about x power to e power equals to 2? It's called Bix XOR operator, not the power. And how I print the value is it's 100. How about if x equals to 10 and x shift left 2? How do you consider the value? It's 40. How about x right shift 2? So the bitwise right shift operation returns the value 40 again. Okay, because that's 40. It's 100, I'm sorry. So when you do the right shift of 2, it's 100. Right shift equals to, my bad, it's 25. So let's consider the membership operations. You know membership operations, if it returns either true or false. We used to do that in and not in, so that's just the same. My string equals to Amulya is in USA. Let's consider my str. Amulya in my str. For strings you have to give the double quotes. So yes, it's true. UK in my str. It says false. What if I say Amulya not in my str? It's false. UK not in my STR. It says true. So that's how we ended with operators. Thank you. Thanks for watching, and please do like, share and subscribe and hit on the bell icon for more updates.